according to what it is said to do, and it is like a human environment. In a human environment, each team is given a specific role, like there is a research team, code team, evaluation team, and this is mimicked in this multi-agent framework, which we learned today. And we'll discuss on communication patterns like messaging, delegation, and hierarchical agents. We'll uh, well with certain debugging techniques you could use in multi-agent framework. And today, basically, we'll be building. Uh, Firstly, we'll be building a 4-agent team, and then we'll do a mini demo of a 3-agent team which uses CrewAI and Gemini. So we start with the first code block, which is pip install -q Google Gen AI, LangChain, Google Gen AI. I've explained what pip install -q and Google Gen AI and LangChain Google Gen AI is. Here, the only new package we have installed is CrewAI. The CrewAI package is the multi-agent framework package. Like previously, we did not need a multi-agent framework package because we were using a single agent. CrewAI provides us with packages like modules like agent. So everybody knows what modules is, right? Modules are the functions that are in a package, and they take parameters, and they are inbuilt functions in a package. So CrewAI has package modules like agent, task, crew, and all, which helps create a multi-agent framework. And the second block is about configuring a Gemini API key. We'll use this because instead of a .env file to keep our API private, I have told yesterday how to get an API key, create an API key using the Google AI Studio, take the API key, copy it, and while you run this code bit, just enter the API key. It will be remain hidden throughout the code, which is reference the Gemini API key variable to run to access this API key. So is everybody clear? And I'll give you 2 minutes time to get up to this portion. So if we have completed up to configuring the Gemini API key, put a thumbs up, or if you have any issues, do let me know. I've still have the panel. Yeah, so does anybody have any doubts or if facing any issues? I've only seen three thumbs up. Are you still doing it? Yeah. So by the time it's executing, I will teach the topic about when to use a multi-agent system. A multi-agent system uses multi-specialized LLM. So an LLM model is a large language models which works on text-based roles assigned by them, or it is a model which works on text basically. And these multi-agent systems are based on LLM agents which have specific roles. So the roles are a research role, code role, review role, and these can be used in product ideation, also research. Each role is given according to the requirement so as to get the agent to work according to what is required. So uh, you can use multi-agent frameworks when you create a project or when it is a high-level project. So if I have to simply write a code about uh, some addition or subtraction, we just need to use a LangChain simple framework. But when it comes to an industrial level or a higher project with a deeper level of execution and complexity, we prefer a multi-agent framework as uh, this framework provides us with different agents who can do their tasks specifically, and they'll only focus on the given task and they'll work with it much efficiently than a single agent framework. So let's get into the code part. So firstly, I have defined a call Gemini function. This will be further used in all the call agents. I mean, all the agents. We have four agents in this model. I have this first code bit that is planner agent, research agent, code agent, and evaluation agent. And all these agents use this call Gemini function to call the model. So this call Gemini function has uh, two parameters, which is the prompt string and the temperature string. So the prompt string is defined as a small helper to call Gemini with a text prompt. That is the prompt string. And the response is collected to client.models.generate content that we have been using this from yesterday. It is used to access the Gemini model with the API key, and the contents of in this contents passed through to this model is prompt because in a planner agent, this is the prompt, and each agent has different prompts which will be passed into the call Gemini function, and I'll show it to you when we call a Gemini function. And the type config is used to determine the temperature. We have dealt with temperature yesterday, which is used to show whether the code is deterministic or it is creative. So we have set temperature equal to zero point 0.2 as a default value. If no temperature is given, it should be deterministic. And if it's greater than 0.5 or reaching to 1, it is more creative. Now we can move into the planner agent. So in the planner agent, we'll first plan on how to do a project. So it has two parts for the planner agent in the prompt. planner agent has a user goal string, which is the goal we have to achieve. That will be uh, that will be defined in the manager phase. That will be the last code bit I'll be dealing with. And firstly, I'll teach about the roles of each agent. And in the planner agent part, the agent's task is given as senior AI architect, and the agent's description. And these are the tasks given to the agent. You can change this according to your need and according to the project you are creating. So the prompts consists of the agent's role, which is the senior AI architect, and the task assigned to the planner agent, which is break this code into 3 to 6 clear ordered steps. For each step, briefly explain what the research agent, coding agent, and evaluation agent should be focused on, and format a plan in the format of step 1, step 2, 3, and then a return call of Gemini prompt with temperature is given. So this is the prompt, and once a Gemini function is called, it will be passed into the model with the content as prompt, model as Gemini 2.5 flash, temperature if point 2 is mentioned, and it'll return with respond.text. Response considers it constructs it is made of the raw text that is passed, that is the result of the Gemini 2.5 flash model, and this will be returned to the defined planner agent model function, and this function will be returned when called upon. The response.text will be returned when called upon. Next is the research agent. Now, each agent gets the data from the previous agent. It is like pipeline flow. Like in LangChain, we use the pipeline flow. Each task is processed after each another task. So once the plan agent is done with its task, then the plan string, that is the output given by this string, is passed into the research agent's code or the research agent's function. Also, the user goal is passed. That was the definition user goal that will be defined in the main operation task manager. I'll get to it. And the previous output, that is the plan string, is passed in the prompt, and the prompt is returned as you are a research agent, which is the role of the agent. The user goal is retrieved. The plan, which was the output of the planning agent, is retrieved. Then the task, what the research agent should do. It should clarify requirements and constraints, suggest a concrete technical approach, list edge cases, and the format of the output we require. So this is what the research agent does. The research agent, uh, first of all, the role, which is a research agent, it is mentioned. The user goal, the team plan is mentioned, and clarifying the requirements, which are the tasks of the research agent. Is all of the agents follow the similar pattern. The research agent, the user goal, team plan, task, and format. But the first agent will not have team plan or the previous agent's output to work with. It will only have the user goal to work with. So when we move on to the next agent, which is the coding agent, I forgot to explain last bit, the return call Gemini, which again move back to the simple Gemini code, where the content prompt is the research agent's code, and then prompt it this much, which you could change according to your use case, and the appropriate response.text is returned when called upon the research agent. So next is the coding agent. What the coding agent does is it takes the user code and the research notes. The research notes here is the notes of the previous agent, which is the research agent. The response text we get when we run the research agent. And this response text is passed to the coding agent, which it will use to code the data. And here we have given the role of the coding agent as you are a coding agent, the user goal, the research notes from your teammate, which are the findings of the data received from the research agent, and the task, which are to write clean working Python code, include small inline comments. At the end, include 2 to 3 simple tests inside its name equal to main block here, which are the tasks that the coding agent should do. And important, which is a framework. In the coding phase, we don't have any framework to dwell with. It will only return the code bit, which is the final code bit. And this also calls the return call Gemini prompt with temperature 0.3, and which gives a response dot text of the coding agent. Hope everybody has understood what the coding agent and the call Gemini function is. If anybody have any doubts, you could ask it. So next, we'll move on to the evaluation agent. Evaluation agent, now it uses the previous coding agent's output, which is the code string, and the user goal string, which we'll discuss. The role of the evaluation agent is defined as you are an evaluation agent and a code reviewer. User goal will be received from the user. Submitted code, that is the output of the coding agent, which is passed into the evaluation agent. The tasks, what the evaluation agent should do: check if the code meets requirements, point out any bugs, suggest an improved version of the code if needed. Format is review strength issues. So that will be it will also provide with improved Python code if needed. If improvement is needed, it will also provide with the improved Python code. So once this prompt is set with the user goal or role and the format and all, and it is passed into Gemini code with this prompt, and the response is taken from the model Gemini 2.5 slash, and it is returned as a response.text when the evaluation agent function is called upon. Now, this is our orchestrator function. We have 3 agents, but without a manager. Like in a firm and all, we'll have different teams, but without a manager, you cannot link these teams. So the manager is the one who calls upon the teams and passes the data to the next one and gets the final output, combines the final output, and he receives it. So also in this define one manual function. This is the multi-agent team function, which takes the user goal, which build a Python function that checks if a number is prime and includes some two tests. Yeah. So first we'll print the user goal, which is this text, and this user goal is passed into the function. Then we will print the planner agent plan. Then we pass the user goal to the planner agent function, which calls the call Gemini function and passes the prompt to the role and task of the planner agent, and it will respond with the output, text output of the planner agent, and it will be printed by using the print plan. So here we could see the user goal is building a Python function that checks it. And step 1, understand so we have given a format by using it should follow step 1, step 2, step 3, so on. It gives step 1, understand by knowledge definition. and the according plan is generated in the planner phase up to step 5. Next, we have the research agent nodes. So here we have the planner agent's output as plan, and the user goal and plan is passed into the research agent to get the research nodes output. So this is the output of the research agent, which has the format of requirements, approach, edge cases, and all. Yeah, that will be the research agents. Now comes the coding agent. This is the agent which creates the code, the final code you'll be working with. And it also takes user goal and the research node as the input. The research nodes is the previous output which we got from the research agent. And the coding agent works with these research nodes and the user goal to generate a text out of code which is given into the code variable. And this code variable is printed in the yeah, coding agent code defined is prime in any name. And this is the final code which is given by the coding agent. Now, similarly, we go on to the evaluation agent, which takes the user goal and code, which is the previous agent's code bit, and evaluates according to its role and tasks. And we get an evaluation agent output. So that's it. That will be the evaluation agents. We get it into a review variable, and we bring the review variable, review of the review, which is the evaluation agent's output. Yeah, so this is the final return plan research notes code, which will be a format where plan is the out the plan phase, the research notes is the output of the research phase, code is the output of the code phase, the review is the output of evaluation phase. So in this function, we call the in this two outputs variable, we call the run manual multi-agent system or manual multi-agent team function, which brings the output accordingly and returns these into the outputs variable. So it's already printed in the function itself. So we do not need to print the outputs again. So this is the first topic we have dealt with, creating a simple multi-agent framework without using CrewAI. We haven't used CrewAI till now. It will be a more advanced model with specific agent tasks and which has functions, inbuilt functions for agent and tasks. So this is a simple model we have created. Everybody could run this model and check if their outputs are correct or they're getting their outputs. If you have any doubts, ask. Give you a 2-minute time to run the code. So I hope everybody was able to execute the code. Yeah. Now we'll move on to a theoretical topic about communication patterns. So I'll be talking about three types of communication patterns, which are the messaging pattern, delegation pattern, hierarchical pattern. The messaging pattern is what we have just done. So we were the user, and the user goal was passed and to a planner, then to a researcher, then to a coder, and to an evaluator. Here the messages are just strings of text, and it is just passed on from one agent to the next agent, and the output of the previous agent is passed on to the next agent, and the simple pipeline framework. Next is delegation pattern, where an agent can be allowed to call another agent. So in CrewAI, we could use the coder agent. After the output of the coder agent is passed to the evaluator agent, the evaluator agent finds out that there is some error with the code and some serious issues have been found out. So it wants the coder agent to rework the code to give a more optimized output. So the evaluator agent can delegate the flow of the work and call back the coder agent and give the output of the evaluator agent to the coder agent, and that will give a new optimized code. That is how delegation works. Or when the coder realizes there's missing info from the research agent, it could ask the research agent to work again so as it could get perfect and good info on the research so as it could give an optimized code. So what third is the hierarchical pattern. So this was also seen in our previous example, where this is the hierarchical agent or run managed multi-agent team function. This function was used to orchestrate the whole different three agents or four agents we have the. It chooses when to start the agent, when to stop an agent, when to call another agent. Like if it feels one agent is taking more time or the output of an agent is only required up to a bit, the orchestrator agent can choose whether to stop the agent, whether to restart an agent. Also, in the delegation phase, we have seen how a single agent can call another agent in the multi-agent framework. In the hierarchical agent, the main manager agent manages each um separate agents and uh, shows how they work and decides how they work so as to get a optimum output. The hierarchical pattern is we learn about is about LangGraph. That is the last topic. It is the LangGraph is a non-linear pattern. We have seen graphs, right? Uh, the Lang chain is a straight linear pipeline, but the LangGraph is a non-linear framework, which we learn as last topic. Now we'll get into the mini model of creating a CrewAI plus Gemini LLM. We'll use the CrewAI package and we'll import the agent, task, crew, process, and LLM functions so as to create specific agents and tasks. So why we use CrewAI this process? It's because it has predefined variables. So consider the agents example. In the previous example, we saw how agent takes a role. Firstly, agent needs a role, an agent needs a task, an agent needs a format, how it should work. So by using the agent function and the through package, it has predefined variables to accept these task, role, and all. and it will be working with it. You do not have to specifically describe the user goal and give the user goal. It has predefined variables. That is the advantage of using CrewAI, and this is computationally very high than simply using a multi-agent framework, and it is more efficient. That is the main difference. Now we'll get into the code of creating a Gemini LLM plus CrewAI shipping environment. So first of all, we'll call the Gemini API key, which is embedded in the variable Gemini API key, and it is moved into a variable. And secondly, we create a variable Gemini LLM, which is used to show through a framework. And this LLM function will be called upon and used to receive outputs. Here, the model is defined as Gemini 2.5 class. So in our previous encounters, when we called upon a model, we just defined Gemini 2.5 class. But while using the LLM function, previously we used contents dot model.getContents to call the model. But here we are using the LLM function of CrewAI package. So we have a syntax where Gemini slash Gemini 2.5 class of this pattern is used so as to get the output, so as to pass it to the model variable. That's a simple difference which we might avoid, and this can cause to error in our code. And the API key is referred to as the Gemini API key, set a temperature of 0.2. Now we get into the task of defining the three CrewAI agents. Here we only use the research agent, coding agent, and evaluation agent. And we omit the planner agent because the planner agent is included in the research agent itself. Sorry for the inconvenience. Yeah, we'll get back to. Uh, so we were talking about the different agents in the CrewAI package. It is defined with the agent model or agent module. The agent modules has parameters like role, goal, backstory, the LLM, which is used to work with the uh, research agent, and the verbose. Here, I hope everybody is okay with what the role means, what the role is, goal, what the task it should do, that is, and what that goal it should achieve. That is meant by goal. Backstory, which is what its backstory is, and it further defines its role, what it should do. You are good at tuning vague user roles. It just gives a backstory, and the LLM is the model we pass. And uh, the previous four variables are self-explanatory, but verbose is new to us. So what verbose does is it just gives a detailed explanation of each workflow. We will see it in the output. Like if we turn off verbose, it will be a short output, and it will not dwell into uh, the workflow of how, like in while using ChatGPT or Gemini, we have been given with a button to see the thinking process. If some of you have noticed, we'll be given with a button to see the thinking process, and that is what verbose does. Verbose parameter is used to, when it is set to true, it will be showing the thinking pattern, and this is useful in debugging. So we have turned on verbose. Here, the role, goal, and backstory, which you could edit according to the agent, or you could edit what you need in the search engine with editing these parameters. So everybody is okay with, I'll just briefly explain what everything is because I'm not going to going in depth of what each role is, what each role is. Similarly, in the coding agent also, we have a role which is coding agent. The specific goal is given, and the LLM is the Gemini LLM we have previously defined. In the evaluation agent also, the role is the evaluation agent. The goal is generated by that code. The backstory is also given. So all these prompting text that are the variables we have entered or the parameters, all these prompting texts could be edited according to our need, and you could do it while you create your project. You could edit according to your need to get more outputs. Also, the temperature could be adjusted so as to get more creative outputs or more deterministic outputs. And that's it about describing the agent phase. Now we'll get into the task phase. So we have now set up each agent with their roles and role backstory and all. And for the task tips in the next block, I've given the task description, which is creating a Python command line script that converts temperature between Celsius and Fahrenheit. The requirements are given. So after this task description, this is the prompt bit to put, which is the task we have to do. You could edit it according to your task or according to your project. We have the research task, the coding task, and the evaluation task. These are the tasks which what each agent should be doing. So we have already defined the agents. Now we are defining the tasks of each agent. The task task module, which is a module in the CrewAI package. This module has the description, three parameters. It has many parameters, but we'll be mainly focusing on three parameters which are important. The description, agent, expected output. These are the three parameters. So the description parameters consists of what the described tasks are, description of the tasks. The research agent's tasks will be understand this is the user goal and propose a short spec, and it will print out the task description, or it will use the task description to analyze the task. And the agent is the specific agent for which this task is being used. For the research agent, the agent is defined as research agent, which is this variable research agent. And the expected output is the prompt of how we require our expected output. So that will be the expected output. All these prompts could be edited according to your need. Now the task coding task, which also defines a description for the coding. The agent is the coding agent, and the expected output of a coding agent will be a Python code block starting with Python and ending with triple slashes or triple columns. Also here we have added context research task. Like I have said when dwelling with the previous four agent model, each agent will be passed on with the previous agent's output. Here context is used to context parameter, which is a parameter on the task module itself. It is used to retrieve the context of the research agent. So the gets the output of the research agent and works with it to generate the code. In the previous research task, in this task function, we did not have a what you say context parameter. We did not use it because it was the first agent we'll be working with while executing the code. Similarly, the evaluation task, in this function, we give a description of the evaluator. The agent is the evaluation agent, how we need the expected output. Here, the context is passed, the research task and the coding task. Both the specifications and the code is passed. Like in the previous model, we just passed on the previous inputs. Like the planner only passes to the research, the researcher only passes to the coder only passes to the evaluator. This is a hierarchical or multi-agent framework which provides a LangGraph pattern. Here, different codes can be, that is, in the evaluation task, the coding task and the research task is passed so as to edit or backpropagate to any of this task or any of this agent according to the managers or the main functions requirement. So it is provided in the context of the research task and coding task. Now, the converter through variables uses the crew module. The crew module is the manager module or the main module we have in the CrewAI package. It has 4 parameters which we have defined: agents, task, process, and verbose. So we, while I first executed this code, as I was preparing, I have just used the agents, tasks, and verbose parameters. But our Gemini 2.5 class model is a free model. Will get exhausted pretty fast. So while running this through model, it will give an error because the quota limiter will be expired. So I used a process variable which processes each task sequentially. So only after a single task is done, the next task will be processed or the next agent will be processed. So for this, I have included the process variable or the process parameter, which processes the tasks or agents sequentially and ensures only one task is running at a time. Because we are using a Gemini three-tier model, it will only able to run a single task at a given particular moment. Uh, so in the agents parameter, we have given the 3 agents, which is the research agent, coding agent, and evaluation agent. In the tasks parameter, we have given 3 tasks, which is the research task, coding task, evaluation task. According to the respective to each agent, we have given each task. And verbose is set to true because we need to see how the thinking process, and it will be useful for debugging. So from google.genai.errors, I have imported client error. So as I told you, while I was first running this code, I have been facing with client error where the Gemini quota was running out while running this CrewAI function. So I edited my code so as if a quota exemption error was met with, it will be, we'll use a try except block, like a try catch block in Python. We use a try except block to catch these errors and show the client error or exception according to what it was. So this is the main code bit we'll run, which is result is equal to converter.crew.kickoff. Converter crew is the crew functionality we have, the multi framework. It is the manager crew, which is stored into the converter crew variable. When we run converter crew.kickoff, it processes the whole agent and tasks and runs the multi-agent framework and gives the final result into the print functionality. Gives the final result into the result variable, which is a text. And this crew module gives a logical operator. Like in the previous framework, we had to specifically decide which the planner agent works first, then prints its output. The research agent works first, second, then prints its output. It We manually wrote that code, but using the group mod functionality, we do not have to do that manually. The kickoff function, when called, when we call the kickoff function, the crew automatically runs the agents and according specific tasks according to them, and it takes the task description. So when you're creating your project for the hackathon, you can edit the task description and edit according tasks and agents parameters to run the code. So finally, we print the result using the print result. This is the result we have got. Crew execution started. So this is the crew output of the crew process, where firstly the research agent's output is got. User goal is printed out, requirements output is printed. So then the crew task is executed. Once the crew task is executed, the research agent is the final research agent output. This is the final research agent output. And the task is completed successfully. Then we go into the coding agent. The second agent is started. Task is given, task is printed, the user role is printed, the requirements output is printed. Then the task is done. The crew process does the tasks and is completed. And finally, the output of the coding agent is printed. The output coding agent. And after the task is completed, we move on to the final evaluation agent, which is the final answer. So once the evaluation agent is run, we get the evaluation agent does not take, it also printed a first description box, but in the evaluation agent, we did not, the crew process did not print a description box. It got into the evaluation process itself and provided us with the final output. So this is the final true results. And it gives us suggest tools, arguments, what works and what does not work, issues or bugs or missing cases, suggestions for improvement. This will be printed in the final true result. So that's it about how we integrate CrewAI and Gemini and how we run a multi-agent model. So in this process, while it was running the evaluation agent, or it was the coding agent. Once the coding agent started running, it first went into a thinking phase, assigned to the search agent. Then it started executing some tasks. Then it again went to the researching agent. So it might have told to update the research agent according if it had met with new functionalities. So again went to the research agent, went back to the coding agent. So the crew process or the crew module functionality uses its own brain or its own functionality to call multiple agents and multiple tasks according to the need. And this is done automatically by the crew agent. That's it. So everybody can run the code bit up to this. And if you have any doubts, you could ask. I'll give you 2 minutes time. Once it's done, everybody could react with a thumbs up, or you could use text box if you have completed it. Today we only have two more theoretical topics, which is about debugging and LangGraph. Yeah. So I'll finish with the topics. I'll head on to the next topic, which is some tips for debugging a multi-agent flow. The first will be like if you have different agents, you can evaluate print intermediate outputs. Like you can print the output of the research agent separately, run that code bit only, and you could run the coding agent code bit only so as to check if that is the required output you require, or you can do edits in the prompts according to the output so as to get the required output, which will be a debugging technique. And lowering the temperature. As I have said, the temperature determines if the model is deterministic or creative. If it is creative, it will be more fluctuating, or it will hallucinate more. It will give errors more if the temperature is high. And if the researcher agent, for the researcher agent, the temperature could be of the range 0.3 to 0.5 because it should be a little creative. But for the coding or evaluator agent, the temperature is optimal for 0.1 or 0 because it should be more precise. The code should be precise as to only follow the syntaxes and the coding language of the coding language you require. So that's another technique. Then tighten prompts. So this is the main function. Why the main functionality of the agent creator is defined by the prompts we define. So each prompt we define makes the agent more efficient, and each prompt in task phase makes it more efficient. So the code is too long. We could use prompts like max 50 lines codes. Only standard libraries should be used. Do not write explanations outside the block. So these could be some example prompts we could use to tighten the output or get the required output. The next debugging option is limit responsibilities per agent. Then third framework, in the second example, we have to use only 3 agents. But in the first framework, we use 4 agents. So 4 agents can be given only certain tasks. While we went into the second example, the planner and the researcher was merged into the researcher agent. So this research, the research agent had the task of planner and the researcher. So this could make some errors while we work with large amount of data. So limit the responsibilities of agent by separating it. 3 agent framework is optimal. So you could also go to a 4 agent framework if it is not working well. Fallback strategy. Multi-agent output is messy. Test each agent individually. Like I have said previously, printing the intermediate output. Try solving with a single well-crafted prompt. Don't get to don't get a lot of prompt into the model. Uh, make the prompt precise and to the point. Reintroduce some agents if necessary. You could delete the whole agent and rework on it. So you could reintroduce them. These are some fallback strategies. There'll be some debugging techniques. Now we learn about LangGraph. Like I said, LangGraph is a graph-like framework. Yesterday we dealt with LangChain. LangChain is a pipeline framework. It moves from one task to another, passing the previous output to the next. But in LangGraph, uh, as you have seen trees or graphs, it can access any other node according to the requirement. So if you are using long running agent or multi-agent collaborations, like we use in CrewAI, the CrewAI was able to call the research agent again. This is why we use LangGraph. CrewAI is a very good example of LangGraph, where we use the LangGraph framework. Traditional LangChain frameworks are linear. It is mostly stateless. It will move from one code bit to the next, one execution to the next. But LangGraph introduces a non-linear model. It will be able to code according to its need, and each agent has state, and it retries and gets the most optimum output. Think of it as LangGraph can be described as LangChain with a state machine with multi-agent orchestration. Like in LangChain, we'll just provide it in a sequential way. But in, but in LangGraph, we provide a state machine, like a state to each agent. Uh, each agent works on a LangChain framework, but once the agent is run, it moves to the LangGraph framework, and then it is orchestrated with a multi-agent manager. That's about LangGraph. The example we learned about LangGraph is CrewAI. Yeah. So that's it for today's topic. If anybody has any doubts, you could ask now. I hope everybody is clear with the topics. Yeah, LangGraph is a theory topic, but the example we did of LangGraph is CrewAI. CrewAI is a LangGraph like framework. It follows the LangGraph framework. Okay. So I'll post uh, today's homework in the group. So the homework, I'll tell it's to modify the agent. So I have given you the agent framework and provided it in the code bit. So you have to modify it so as to create a simple API powered microservice or a notebook based tool like a CSV analyzer. You just have to edit the prompts in the task description, the task prompt, the agent prompt. These all should be edited, and you'll get your output, or you'll get your homework done. So if anybody has any doubts, it has conclude my session. Arnav, can I conclude my session?
Yeah. So thank you, everyone. The session has been done.